do we need to do to protect ourselves from those fears?
Well, I think if you take any DNA framework and put it under a heat lamp, and you have human DNA, eventually it will evolve structure. Once it has evolved structure, it will speak. Once it will evolve structure, it will see. Once it will see, it will speak. When it will speak, it will think. And once it will think, it will predict. So that's intelligence. So that's why language and vision are the most important part of our intelligence. Probably intelligence is vision raised to the power of language. So how do we build that now into silicon, straight? We don't need consciousness as a substrate, so we left that behind. So there are two schools in AI now. There's what I call the old school, and the old school is the school who does statistics programs in R and uses MATLAB. And they use discriminate means like support vector machines, decision trees, things you can sort of explain. And there is a new school, which has an enormous success, the connectionists, deep neural networks, unsupervised, very deep, lots of dimensions that we can reduce. These schools have, in the last 3 years, have 37% error correction. So they are now surpassing humans, basically. The only problem with that school is, and that school doesn't use, or hardly uses statistics, more like multivariable calculus and Python and deep neural networks. That school has one barrier against it, that in healthcare, doctors want to be able to understand why these black boxes tell us what to do, while actually medicine is the biggest black box of all. It's completely qualitative, very, very small, data, symptoms. We are no longer in the symptom age. We are in the age of algorithms. So that's going to be the big thing. How can we convince doctors that, as in mathematics, we have different fields we don't understand, we just bridge it over, Ramanujan, we still don't understand how he came up with the infinity. And we have to do the same with these black boxes. And we now have great tools like stochastic gradient descent, where we can sort of control it. But it's a leap of faith.
Yeah. So Ron, yeah.
Yeah, so I want to go back to, there's all the big picture things that are very, very important and fascinating, and how we tie them all together to get a great understanding of the human, and it creates a big level of interest, but also complexity. That is kind of like scary, right? So instead of that, I keep thinking to myself, or maybe because I'm an entrepreneur, I keep thinking about MVPs all the time. What's the minimally viable product that we can do today to solve a human problem? You talked about a tool, Boot. You talked about Einstein, right? Like talking about what question we're asking and what problem we're trying to solve today with the tools that we already have in hand to help people accomplish something in the next 30 days, 60 days, 90 days with fantastic tools that we already have today. So let's think about this way for just a second, right? What can we do with AI, right? So we used AI in the past 20 years in Silicon Valley to be able to do behavior change in commerce, right? We're taking people now with ads, right? We use ads, words, pictures, videos, and making people that used to buy one product buy the other product, or take people that used to buy no product and buy a product or a service, right? Mm-hmm. So we are able to understand user behavior in commerce in a way that causes behavior change in commerce, right? Hold on one second. We perfected that in the last 20 years in Silicon Valley to an art, right? Like we're doing it really well. Google does it really well. Amazon does it extremely well, right? Netflix is doing it amazingly well. Why not apply exactly the same frameworks to behavior change in healthcare? Mm-hmm. Rather than making you buy, a ticket to a show or this laundry detergent, why don't we help you take your medication using exactly the same tools that we perfected in the past 20 years using words, pictures, videos, right, to help a patient take a medication, that they don't take more than 50% of the time after prescription, after they take it, use a medical device, right? Get another doctor appointment or a test done and interpreted. These are all small, simple actions that they should take to get to a better outcome that we know will happen. Right? So we have the tool set in our hand. This is what these companies are using AI every single day. So we are hiring now these data scientists that are doing it in ads. And instead of serving ads to people, HealthHub could have made exactly $120 million in the past two years in just serving ads on our pages. We're not doing any ads, but we're hiring the same machine learning people and data scientists to start using exactly the same tools to convince people to take a medication or use a medical device. This is a good use of AI.
Hang on a second. So I'm not getting anyone here to bite on where we're really going with this, like some of the darker, things that might happen. I mean, there are people who talk about, privacy. We've talked about that today. We willingly give up our data on the one hand, and we freak out about our medical data. I think that was a very good comment that, just kind of depends on if we get some use out of it or we think we get use out of it. So there's the privacy issues, a lot of ethical issues. I mean, we're going to be turning over, one of the nice things about AI is it processes this data, connects it, it sees patterns, but it also hands it off in ways. And we are used to doing this with banking and some other things. There's also issues about, John, I might ask you about, is your job going to be replaced by a robotic equipped with AI at some point? I mean, you're already seeing
so
like
a lot of people. I'm not worried. A lot of people are inverting the AI and coming up with IA as intelligence augmentation, and I think that's much more realistic about what we're going to see. And the hope is that rather than disintermediate everybody in what they currently do, is to augment what they do with intelligent augmentation of all sorts, not just machine learning, but robotics and the whole spectrum. And so we can upskill everybody. The problem that I see, and I blogged about this yesterday, is that this intelligent augmentation may be disproportionately effective for those at higher levels of access to education and socioeconomic status, and that we may see an acceleration of the social inequities. And that's part of what Cathy O'Neil talked about in Weapons of Math Destruction, is there's inherent biases towards social inequity in the machine learning black box. So that's why I've been very interested in the Diadarity and how do we provide a level of transparency. So there's a fellow in Silicon Valley with a startup. Biomimicry, by the way, has been phenomenal in terms of helping us understand how to tune what machine learning does. Machine learning basically operates on a pyramid of algorithms, and there's a reason that our brain cortex is called the pyramidal cortex. It's very similar in how it works. The big difference to date is that almost everything in a traditional machine learning stack is feed forward. There's very little feedback. And the brain has lots of feedback loops. And so transparency may be a collateral benefit of providing more of a feedback process within machine learning than exists in most models today. And there's people, as I say, working on that. There's also people at Intel who are working on, not to call them out specifically, because other people are working on it, but Intel is looking at how to instrument what goes on inside the processor to provide more transparency in the black box. So how we provide that transparency will not only help us accelerate how to learn using machine learning and large data sets, but will hopefully give us some sort of transparency into what's actually going on. The FDA is profoundly worried about this. The FDA is incredibly interested in reinventing themselves, recognizing this new reality of the black box world that we're entering in. You put data in and you get an answer out, and how do you know? And if overall everybody's better, but occasionally you kill somebody with a really stupid mistake, what does that mean in terms of policy? What does that mean in terms of FDA approval? We need to have a whole different way of looking at the transparency and what goes on inside that black box.
No, in fact, that's a whole other area which is fascinating. How is this regulated? I mean, the FDA is having a hard time, and a lot of other new technologies, keeping up, with technologies from invented 15, 20 years ago, and this will be a big change. But let me, in our last few minutes here, open it up to you all. We could, obviously, this is another enormous topic we could spend a lot of time on, but you all hopefully have been pondering this. Any questions out there? Yes.
Yes, hi. My name is John Meyer. I'm a pharmacist and a scientist, both working as a director of pharmacy here in New York City for many years, and also for a pharmaceutical company for many years as well. I was especially intrigued by Dr. DeBrouwer and, of course, the whole panel, but talking about old school and new school. And I recently finished a book called The Undoing Project, and I think you would all probably be familiar with the work of Kahneman and Tversky. And I'd like to see what you think about whether they're considered old school, new school, or some sort of hybrid, if you're familiar.
Well,
I'm
it's a
assuming you're
hybrid
familiar with them.
It's a hybrid because, you know, a lot of people from the old school are my friends.
So you have to be nice.
But, you know, also the dominant university has been, you know, it used to be, you know, MIT. Now it's clearly Stanford for language and vision. So everything is changing, and especially with, with Python coming into the mix and things becoming, you know, and TensorFlow as horizontal AI. But, you know, coming back to that black box thing, so isn't is a machine where you put things in and things come out and you don't know exactly what's going in between, that should be, if that should be actually regulated by the FDA, then every doctor should be a 510K. Because the doctor is the ultimate black box. And makes a lot more mistakes than our black boxes.
Mm-hmm.
Okay, let's grab another question. Maybe, yeah. Let's go over here, and then.
Walt, you said before it was unclear how to get doctors to adopt the outcomes of black boxes, but it seems to me that data and outcomes would be very persuasive. So if you were able to show a doctor that the output from a black box was able to diagnose or lead to a better treatment than would otherwise occur, that would persuade doctors. Do you think otherwise?
It is. So I don't know, you know, in the 90s we made WordNets, you know, for computational linguists. Then ImageNet came now. Last week, Stanford open sourced Medical ImageNet. 0.5 petabytes of data, 1.2 billion radiology images, 4.4 narrative radiology reports, 23,000 conditions. There, radiologists are convinced because basically the machine does a better deal than, you know, than a carbon-based unit. And so I think they.
Unit.
Yeah, so.
It's true.
Although it's a black box because this vision, you know, Inception 3, which we use, is basically, you know, deep neural network.
But it doesn't need to be a black box. I mean, everyone's talking about the black box. I think that we can actually leverage the fact that we have a lot of doctors out there, not an individual doctor or an expert, but actually take the physician community, right, and help them open the black box to them, right? Tell them how the method works. You know, what are the algorithms that we're using? And more than that, when the machine starts spitting back results, we've done it with Dr. AI. What we did is we trained the algorithms, we got the result, we broke it down to individual results, we start sending it to physicians one by one. So a set of symptoms, context, right? And here's the outcome, and let them vote yes or no. Not one physician, not a panel of 10 physicians, but more than 10,000 physicians, right? In 141 specialties, allow them to say for individual results, yes or no. Wait until a statistically significant number of doctors answer either yes or no to either retrain the machine when it's a no, right, what the physician community thinks, right, or say yes, enough physicians, right, that each and every one is individually trained think that at least what the machine is doing is right. And then you can retrain the machine again and again and again. It's an organic thing that actually works together to make the machine better all the time when you open the black box to the physician to tell them how it's computed. Yeah. Now you have visibility, and nobody's concerned about that.
Yeah. I have another one.
Quickly. I want to get another question.
For us, for molecular biology and bioinformatics, our black box does need a predictive analytics, and it has to be experimentally tested. And actual percentage of accuracy is not based on the black box predicting. It's actually the experimental validation done by scientists of our predictive analytics. And then from there, not only experimentally validation, publish it, but also going into, for instance, using the Cancer Genome Atlas, the TCGA, and looking into 10,000 or more, almost 20,000 cancer patients, and finding the same correlations that your predictive algorithm found, and then testing it back in mice and then in further patients. So unless we do that with our black boxes, then our scientists, at least for us, are then saying, okay, your predictive power, I guess, is true.
Well, this is best to trust. I mean, we have a lot of black boxes we deal with in other industries we use all the time. So anyway, let me get one more question here, bud. Sorry. Yeah, right over here.
Hi, thanks. Dimitri Kofinas. Two things. One, a sort of observation on something that Dr. DeBrouwer said about the black box. I think it's true that each physician is a black box and that they're qualitative. However, a patient can ask for an explanation from a physician and derive some sort of answer and response. I think the concern with the algorithms is that we don't understand that process in the soup. And there are so many variables that are coming in.
You can derive the same thing from a machine.
There's bots.
So we now have, so Stanford has Squat, which is the big data set with inference. It's pretty, it's now possible actually with like 72% of accuracy that the machine unsupervised goes to look for things that it can explain. Because basically it's a bit like when I sit before a student and I ask him a question, he's first going to give me a definition from a textbook. Now I'm going to find out if he really understands, say it in your own words, and then I'm going to make him or her reason to see if these steps are there. The same thing we are now working on for machines, and I think the paradigm shift in language and reasoning will come in probably next year or the year afterwards.
Unfortunately, we're going to have to leave it.
I think it was just about the foundational mathematics points you were making on the
You guys,
paradoxes.
unfortunately, we're going to have to leave it here, and we can pick it up later. I was under strict instructions to end on time. So
We will
anyway.
stay here. We can talk
Yeah,
about that.
no,
Yeah.
listen, these are all amazing topics, and I think this fall at Techonomy on California, we'll talk more.
Can I
So,
just say 1 second?
Yeah.
So there are other things we
Okay,
do,
that was-
clinical trials, cell lines, organoids. We're not going to eliminate those. That would be a very bad idea. We also have mechanistic explanations. We look at pathways, we look at gene regulation. We also do that kind of causal structures. I don't think black box eliminates any of those. We're not going to shut down clinical trials, FDAs. They need to be integrated together.
Absolutely.
well, I want to thank our 5 black boxes here up on the panel.